Hello, class, and welcome to Module 1. In this video, I want to go through the different reading materials, the overview and objectives, and helpful tips to help you prepare for the assignments and the assessments for this particular module. Each module, you will have an intro video, and this is where this video will be located, and you'll see it for each of your modules. Very important that you go through each of these intro videos because it's going to guide help guide you through the material that you'll be covering in that module. And for the disclaimer, while there are no date restrictions on your modules, focus on completing this before the second week of class if you want to stay on a weekly schedule. And so each module will have a CLO, and that stands for Course Learning Objectives. And this course learning objective for this module will be number 1. And you can find all the course learning objectives in the syllabus. So let's start with the overview and objectives. In this module, we will study the nature of matter. After going through all this module's learning material, reading, and activities, you will understand the difference between extensive and intensive properties, the difference between homogeneous and heterogeneous substances, the nature of matter and how physical properties can be useful, the metric system and how to use measurements, the factor label method, units, and how to use them. The objectives for this module. The first thing you want to do is make sure you register for and download the free text, and it's the Chemistry Atoms First 2E. It's in OpenStax, and here's the link for that. You want to understand how this course works. You want to introduce principles of matter, introduce the metric system, introduce practicing and mastering unit conversions using the factor label method, introduce extensive and intensive properties of the sample of matter, define heterogeneous matter and homogeneous matter, classify properties as a physical or chemical property of matter, introduce names and abbreviations of the SI base units and the SI decimal prefixes, introduce meanings and use of derived units, and introduce unit conversions from English to the metric system. And then within this, you have different key terms and definitions. So we have a unit 1 and a unit 2. So make sure you go through the key terms for unit 1, gives you the terms as well as the definitions. This will help you understand the material that you will need for the quiz in this particular module. There are also different readings that help you understand the material a little bit better. The Module 1, Unit 1 reading, and so there's observable properties of matter, physical and chemical properties, the different states of matter, pure substances versus mixtures, and how do we classify matter? All right, so that's all important information to help you with this. And then the unit 2, these are the key terms and the definitions associated with them. So we are going to be doing a little bit of math for this particular module. And so we're going to look at units of measurement. We're going to look at the SI system in units, which is also the metric system. We're going to look at the base units, okay? We're talking about grams, meters, those types of units that is going to help us understand measurements a little bit better. And then we also look at units outside the SI system. So that would be our English units. So those would be things like pounds and inches, things like that. There's some videos to help you understand matter. All right, so there's a couple of them here: physical and chemical changes of matter. The states of matter was in the previous one, and then a couple of more videos on the states of matter. All right. And that's just to help you understand the material just a little bit better and understand what are those different states of matter. Now we do have our unit conversions. And so this is through Khan Academy. One thing I want to give you a heads up, when you click on the link, it's going to give you this link. You do not need to give a gift or anything. This is a free use for you. All right. And so you're going to click that off, and then you're going to go through this information about the intro to ratios, basic ratios, whole ratios, and a review. So you're just going to click on start, or you can click on the videos to help you understand the information. But you're going to be doing some practice problems, and this is going to help prepare you for the quizzes that you'll be taking for the quiz that you'll be taking for this module, as well as the lab assessment. And so make sure that you do go through those ratio videos and those practice problems. And so we have metric system one, we have metric system two. So this is the same thing. This is through Khan Academy. Very helpful resource. And again, you want to click the X button or the X for that because you don't have to, so you won't have to worry about. Sorry about that beeping. I don't know if you heard that. It's my speaker telling me that battery's running low. But anyway. All right. So on the second one, it goes straight to the practice problems. And so you do have this nice reference sheet. This gives you the qualities between the different units. And so that's very helpful. And then it also gives you a nice video on converting the metric units of length. All right. And so this goes through, if this is your first time converting, okay, every time that pops up, remember you can just exit that out. Then it's really helpful to go through the video. And so I do want to show you this one. Let me see if I can get the volume. Okay, I'll let you read that. My volume on my speaker, I need to charge it. And so this goes through basically how you're going to determine going from one particular unit to the next. So if we're starting out with 2 kilometers and we want to go to meters, okay, we're going to take 2 times 1,000 because there are 1,000 meters in 1 kilometer. And so 2 times 1,000 will give you 2,000. We do the same thing if we have 11 kilometers. So 11 times 1,000 will give you 11,000. If we want to go from meters to centimeters, there are 100 centimeters in 1 meter. And so that's what's being written up here. So 1 meter is 100 centimeters. And so if we start off with 2,000 meters, then we want to convert that to centimeters. And so we can also have the equality here that 1 centimeter is 1 over 100 meters. All right, so we have 2,000 is the number of meters, and we want to multiply that by 100, which is how many centimeters in a meter. When we do the math for that, I'm trying to go in rhythm with the with the video here. All right, so they're explaining that you're multiplying the 2 times the 1 to give you 2. You have these 3 zeros, plus you have these other 2 zeros to give you a total of 5 zeros here. So it's 200,000 centimeters. All right, so you're going to do the same thing basically with the 11,000 as well. So you can watch through the video, that'll help you. And remember this reference sheet. So when we looked at 1 meter is 100 centimeters, 1 kilometer is 1,000 meters, that's where those equalities came from. So if we're going from 11 kilometers, it looks like, oh, okay. So 11 kilometers, 375 meters, and we want to know how many meters is that? So we need to convert 11 kilometers to meters first, and then add that number to the 375 to give you how many meters you have, all right? And so we know that 11 kilometers, all right, is we need to multiply that by 1,000. So that's going to give us 11,000 meters. So 11,000 meters plus the 375, you have 11,375 meters. All right. So if you have questions as you're going through this, you can always check your answers. You can skip some problems, just go through. This gives you some great practice, okay? And so that's the purpose of that assignment so that you can get extra practice before you take the quiz. And then this is additional information about the history of the metric system. So that gives you a little information about where the metric system started and where we're going from here. So now we get to our first assessment. This is Module 1 activity, the law of conservation of matter in the real world. So the law of conservation of matter states that matter cannot be created nor destroyed in a closed system. It only changes form. While this is often studied in the lab, the principle is also seen in many real world situations. So you're going to choose one of the five examples below, and you're going to write an essay of at least 200 words explaining how your chosen example demonstrates the law of conservation of matter. In your response, you want to be sure to clearly describe the example, explain how matter is conserved in the process, if there is a chemical equation related to the example, include this in your essay and provide at least one reference. It can be the textbook, a scientific article, or a reliable website. And remember to cite your reference in APA style. And if you have questions about APA format, please let me know. All right. And so, your examples. We have campfire or bonfire. Wood seems to disappear as it burns, but the atoms are rearranged into ash, smoke, carbon dioxide, and water vapor. Number two, rusting of iron. When iron rusts, it combines with oxygen from the air to form iron oxide, showing matter is not lost, just transformed. Respiration. In breathing, glucose and oxygen are converted into carbon dioxide, water, and energy, but the total matter remains constant. Composting. Food scraps and yard waste decompose into soil nutrients, but the mass of organic matter is conserved through breakdown and recycling. Melting and freezing of water. Water changes between, excuse me, solid, liquid, and gas states show matter is conserved regardless of its physical state. So the length is a minimum of 200 words and includes at least one reference in APA format. Be specific in explaining how the law of conservation of matter applies to your example. All right. And so the due date that's listed here is the due date for when I made this video. If you have a different due date for the term in which you are taking this class, please refer to the due date that's listed in your module assignments. All right, and so the next thing is the quiz. So we're going to go back to modules. You have 10 points for the quiz. All right, just note that you only have one attempt for the quiz, so it is very important that you are prepared for the information, that you understand the information. So, how do you fully understand the information? Make sure that you go through each unit and the information that is given, that you do the examples, the calculations, and if you have any questions, that you reach out to me before taking the quiz because I want you to do your best on the quiz. And so it's important that you really understand the information. The last thing is the lab assessment. So for the Module 1 lab assessment, we are looking at significant figures, all right? And you may want to do this before you take the quiz because this will give you practice on significant figures. And so up here, it talks about the rules for significant figures. So I want to go over this with you. So a non-zero digit, that means any numbers there where there's no zeros in it. All of those digits are considered to be significant. So, what do we mean by significant figures? When we're doing calculations in chemistry, there are numbers that we consider to be significant or what we use to count to determine how we round our final answer. Because as you know, when you're doing calculations and you type it into your calculator, sometimes your calculator gives you this very long or very large number, and you want to figure out how do I round this? Do I need to report all of these numbers in my final answer? And so significant figures are our rules of determining how we round our final answers. And so I want to go through those rules. When I'm going through these rules, keep that in mind. We're not saying that those numbers that you're using or that you get when you calculate your answer are not important. No, what we're saying is that when we're trying to determine how to round our answer, we use these rules to help us determine that. All right, so non-zero numbers, they're always significant. So 3749 has four significant figures. Our leading zeros, these are zeros before a number. They are not significant, so there's no digits to count. So 0.00056, these three zeros, yep, three zeros are not significant. What we call these zeros, we call them placeholders. So the value is important because they are placeholders, but when we're talking about rounding our final answer, we do not count these. So we only count the 5 and the 6. So we would have two significant figures. For captive zeros, these are zeros between two numbers. We also call them sandwich zeros because they're sandwiched in between. It doesn't matter how many zeros are in between two non-zero numbers, they're always significant. So that would be all. So 5.007, those two sandwiched or captive zeros are significant. So there are four significant figures. Trailing zeros. These are zeros after the last number. And so there are a couple of categories that trailing zeros fall under. So if there is a decimal point, it has to be a visible decimal, then the zeros count. If there is no visible decimal in the number, then the zeros do not count, but they are called placeholders. So the number 100. There's no visible zero here, so only that one. The number one is significant, so we have one significant figure. 100 with a decimal. There doesn't have to be anything after it for chemistry. So we can just put a decimal at the end of our number. As long as it's visible, all of those trailing zeros are significant. So 100 with the decimal gives us three significant figures. If we have 100.0, every trailing zero is significant put because that decimal is there. So that would be four significant figures. 0.0100, the zeros in front are placeholders. Okay, those are our leading zeros. They're not significant. But because that decimal is there, the zeros at the end or the trailing zeros are significant. So we have one with the last two zeros, that's three significant figures. Okay. If we have a number written in scientific notation, the number before that times symbol or before the X, those are all significant. So 1.7 times 10 to the negative 4, that 1 and the 7 have two significant figures. 1.30 times 10 to the 8th, 1.30, those are three significant figures. So anytime you have a number and you don't know how to write it so that you show two significant figures, like for example, if the calculator gave us 100, we can't put a decimal there because that would be three significant figures if we only wanted two. And so, a nice way to do this is to put it into scientific notation. And so, we would say that would be 1.0 times 10 to the 2. Okay, that would show us two significant figures and still show that the number is 100, right? And so if you have questions go as you're going through significant figures, please let me know. All right. And so then there are rules for when we're calculating with significant figures. If we're doing adding and subtracting, we look at decimal places. And so if we look at this example, we have 1.457 and 83.2. 1.457 has three numbers after the decimal, or three decimal places. 83.2 has one number after the decimal, or one decimal place. We always go with the fewest number of decimal places to round our final answer. So because this number has one decimal place, we want our final answer to have one decimal place. So in the calculator, we would get 84.657. We want to round that to 84.7. Just as a reminder, we want one decimal place. So the 6 is what we're going to keep. We look at the 5 to see if we round it up or we keep it the same. Because this is a number 5, remember 5 or greater, we round it up. Less than 5, we keep it the same. All right. So let's look at the next number. 0.0367 has four decimal places. 0.004322 has six decimal places. When we subtract the two numbers, we get this answer, but we want to round it to four decimal places. So we round it to 0.0324. All right. And so that's for addition and subtraction. Multiplying and dividing now, we look at the number of significant figures and we go with the least, and that's how we round it. So 4.36 has three significant figures because we have no zeros. 0.00013 has two significant figures. These leading zeros are not significant, right? So our final answer, we want to round to two significant figures. So when we get this number, we round it to two significant figures. If we look at division, 12.300 divided by 0.0230, the top number has five significant figures because these zeros are the trailing zeros and there's a decimal present. So all five numbers are significant. 0.0230, the leading zeros are not significant, but because of this zero, the trailing zero is significant. That has three significant figures. We want to go with the least. The least is 3. And so we round our final answer to 535. All right. And so that's how we do use our significant figures. The next thing we look at is the factor label method. In the factor label method, this is where we're going from one unit to the next. We looked at it previously with the con assignment, all right? And so if we look at another example, I want to note that when we are looking at are calculations involving units, all right? So if we have, for example, 2 feet times 2 feet, we are not only multiplying the two numbers, which is 2 times 2, but we're also multiplying the units, which is feet times feet. So that would give us 4 feet squared, all right? So remember, if we are multiplying or dividing numbers with units, we want to multiply and divide the unit as well. All right. So let's look at this example. We have 10.0 grams of water as ice times a milliliter over 0.917 grams of water as ice. If we look at the units, we have grams of water as ice on the top and grams of water as ice at the bottom. Anytime we're dividing the same unit, we cancel those units out, all right? And so we're left with just milliliters. So since we're converting from grams to milliliters, we want milliliters to be our unit. So if we look at the significant figures, so we have 10.0. Because of this decimal, those two zeros are significant. That gives us three significant figures. For 0.917, that leading zero is not significant, so it gives us three significant figures as well. Since they're both 3, then our final answer is 3 as well, so 10.9 milliliters. All right. Then we're going to talk about moles. So we have what's known as Avogadro's number, which is 6.02 times 10 to the 23rd whatever the things. So the things could be grams, I'm sorry, the things could be atoms or they can be molecules, all right? And you're going to look at that in these calculations. And then you start to get your problems, all right? And these are all fill in type problems. And so you're going to type in your answers directly into the answer box and make sure that you read the questions thoroughly and that you show all of your work. Okay, see where it says show all your work for full credit? Very important. All right, these are worth 3 points. You don't want to get partial credit or lose points because you didn't read the instructions carefully. So make sure that you read the instructions carefully. If you have questions, all right, please reach out to me and let me know. All right. And that is all that you'll be doing in this first module. All right. If you have questions, like I said, reach out to me, let me know, and you can send me an email or give me a phone call, and I will look forward to seeing you in Module 2. Have a great module.